Good day, viewers. This is Ademola Johnson, your chemistry tutor and your biology tutor. Please share this video, like it, and subscribe. So we are continuing on stoichiometry. Let's go and look at methods of preparing. Methods of preparing. Methods of preparing a standard solution. Methods of preparing a standard solution. There are two methods. There are two methods of preparing a standard solution. These are, number one, we have a measurement method or gravimetric method. Gravimetric or measurement method. Number two is called dilution method. Dilution and serial dilution method. So let's look at gravimetric method now. Of preparing a standard solution. Now, for instance, if you are asked to prepare a 0.8 mole per dmq Na to CO3 solution, the following steps must be taken. Step 1. First thing to do is to convert these units from mole per dmq to gram per dmq. Now, first step is, now try to convert the SI units from mole per dmq to a value in grams per dmq. To do this, use the following formula. The formula is now molarity or molar concentration equals to mass concentration over molar mass. Now, the molarity I've been giving to you here, which is 0.8 mole per dmq. Then you are looking for the mass concentration, mass strong, over molar mass of Na2CO3, of Na2CO3. Knowing that your Na is 23 times 2 plus carbon is 12 plus oxygen is 16, but you have 3 here. Then you have then you have mass concentration. If you do this very well, you get 106 gram per mole. The SI unit of molar mass is gram per mole. Now, having done that, the next thing to do is to cross multiply. We now have mass concentration equals to 0.8 times 106. Now, what do we do next? We press the calculator. Now, let's try to do that. 0.8 times 106. Answer is 1 concentration now will now be 84.8 gram per dm. 84.8 gram per dm. So let's assume that the concentration, let's say it is 0.08. 0.08. Then I will change this now to what? To 0.08. So this one is 0.08. This one will be 0.08. So let me use 0.08 now. That thing is too large. 0.08 times 106. Answer is 8.48 gram per dm. Yes. What we are saying here, the interpretation of this is that this means that 8.48 gram of Na2CO3 would be dissolved in 1 dm cube of the solution. Recall that 1 dm cube is the same as what? 1000 cm cube. Now, what does that mean? From here now, you now know what to do. So you have done that. Then step 2. Step 2. Now, measure about 10 gram of Na2CO3 and heat it to drive away volatile impurities. So what am I saying? What do? You use your weighing balance. This is a weighing balance. This is a weighing balance. So when I put it on, now, this is sodium thiocarbonate 4. So, what do I want to do? Now, watch me now. Now, this is the weighing balance here. This is the weight balance. So, now, I want to put it on. So, I put it on from here. Now, I put it on. You can see 0.0 gram. So, I am going to measure 10. Why am I measuring 10? The 10 is above the 8 point something I want to measure. You can see the number increasing. This is 6.1, 6.9, 7.1. Now I have 8 point something. I'm going to 10 or more than 10. This is 10.3. I can manage this. So what I would do with this 10.3 is to heat. Don't forget, if this thing contains certain amount of water before, that water will add to this 10. So either I want a pure solute that does not contain any volatile liquid. That's the essence of heating, to drive, to evaporate any volatile liquid. I haven't done that. By the time I reweigh, I will not get that 10 point something. This thing would have dropped down to 8 or 9 point something. and out of which I need just 8.48 gram. I need just 8.48 gram. This one out of this thing. So what will I do now? 8.4. So I have this 5.2. So let me add more. 5.2, 6.6, 6.9, 7.2, 6.6.9, then 8.2, and I'm going to 8.48, 8.2, 8.5, and 8.48. They are similar. So you have seen it now. What I have here is you can see 8.5. So now with this, I will now locate a volumetric flask. This is a volumetric flask. This is a volumetric flask. Look at it very well. You will see that they write, what number do you see here? 1000 mil. That is 1000 cm cube, which is the same thing as 1 dm cube. So, and there is a tiny ring here, line, at this place. Very tiny. If you are not careful, you may not see it very well. One tiny ring of line. So what I will do is that I will now take this 8.5 gram, which is from 8.48. I will now pour it inside the volumetric flask. Can you see what I am doing here? So then, having done that, I will now make up the solution to 1000 cm cube. So how do I do that? Then I can pour this. Can pour distilled water now inside this. I'm pouring distilled water inside this. So this meniscus has not gotten to where I want it to get to. So I will add more water. Good. Now you can now see that this ring, this is a ring. So what I have inside this solution now, what I have here now, inside here now, what I have here now is 8.5 gram of Na2CO3 inside 1000 cm cube of the solution. Take note of one thing. It's not 1000 cm cube of water. No. The 1000 cm cube is for both the solute and the water, both the solute and the solvent. Adebe, I want to prepare, Adebe, it is 8.5 gram in 1 dm cube of water. I will first pour the water to get to 1000 cm cube first before pouring. By the time you are pouring, then the water will leap up above the 1000 cm cube. So, but you are making it up so that the 1000 cm cube is going to be for both the solute and the liquid, the solvent. So that is, then I can shake it until it dissolves. So the concentration of this solution is 8.5 gram per dm cube of the solution, not 8.5 gram per dm cube of the water. No, it's of the solution. So now I say measure 10 and heat it to drive away volatile impurities. Step 3 now. Step 3. Measure about 8.5 gram or if it is 8.48, let's work with what we have. 8.48 gram of the dried Na2CO3 and pour it inside a volumetric flask. And pour water to make the solution up to 1000 cm3. I prepared a standard solution, and the concentration is known. So the concentration is then what? 8.48 gram per dm3. That's what you have prepared. A solution whose concentration is known. There is a question I usually see. That question is that why is sodium hydroxide not suitably used in preparing a standard solution? It is sodium hydroxide because it is deliquescent. Let's see what I'm saying. What do I mean by deliquescency? Let me pour it out. Look at it now. What do you notice? You will notice that after some times, it will be sweating. The particles will continue to attract the absorbed water